Okay, so we are now beginning on with our algebra unit. Sorry, not algebra, we're beginning with our geometry unit. So let's take a look at a few things that are going to be changing about geometry. When you come to class, paper, pencil, geometry textbook, and occasionally your math book. For your paper, I want you to have this ideally in a notebook or a folder with loose paper that you can refer back to. You're going to be making a list of terms that you want to have the definitions easily accessible, as well as a list of formulas as we come across them. Your textbook does not actually have a formula chart to refer to because you're discovering these as part of the process, so make sure you have something easily accessible. Pencils, those of you who are still taking notes in pen and doing your math work in pen, you need to make sure you have pencils. Everyone needs to make sure you have erasers because with geometry comes a lot of drawing and you're going to be making mistakes. Recommended to help make the drawing process a little bit easier, especially when it comes to making circles or any of the shapes with straight edges. Have a compass, right, and a compass down here as an image. All right, not something you're using to help you if you get lost in the woods, but something to help make a circle. You also need to have a small ruler or a protractor. Protractor is great in the fact that it has the angle parts to help you make nice angles, but it also has that straight edge part to help you make whatever object you're trying to create. Let's go ahead and take a look at our lessons. So today we have, apparently, not a working board. Take two. All right. Today we have the building blocks of geometry. So we're going to be focusing on what makes geometry geometry. As we go through this, we're going to be working on writing our own definitions so that things are easier for us to remember, and that's going to be different from person to person. We'll be starting the notebook that we've talked about as part of this process, and then, of course, as always, we are developing our visual thinking. The building blocks of geometry. These are the three most basic things when it comes to geometry. It's weird that we're trying to define them because it's almost impossible to define them. For example, a point. A point is the most basic building block of geometry. It has no sides. So the fact that I am using a pen to try and illustrate what a point is, it's even smaller than that. I mean, point is just a location, but we have to mark it with something to make our eyes able to see it. So we're demonstrating examples of it, but even these examples are never going to be as exact and precise as the real definition. When we talk about points, of course, we draw our point, usually a little bit exaggerated like that, and we label it with a capital letter. So that's basically how to identify a point. A line is a straight continuous arrangement of infinitely many points, has infinite length but no thickness. So we're just going in a direction, continuing on and on. And to show that we're continuing on, that this is a line versus a line segment or array, is we have arrows at both ends of our picture. So this shows us that, okay, even though I've run out of space or I don't want to keep drawing this line infinitely, it will continue on. So infinity means it doesn't stop. That's what we're talking about. On the line, we will have identified some points and given letters to them to help name them. So when we talk about the point, when we talk about the line, we identify it by capital letters representing those points, and above the capital letters, we draw a line with the two arrows. So again, this tells me that I'm talking about line AB. I can pick any 2 points on the line. The order does not matter when we're talking about a line, since there are no endpoints and there are to give us a stopping point. So I can pick any 2 points. I could have said AC, I could have said CA, BC, CB, etc., etc. Now a plane is taking a line and then expanding it widthwise. So it has infinite length, infinite width, but no thickness. Kind of an easy way to visualize what that is to look at a piece of paper. All right, a piece of paper is a segment of a plane. All right, so it continues on beyond the length and beyond the width of the paper. But even a paper is still thicker than a real plane. So it's a little bit interesting to imagine what all is going on here. Okay, let's take a look at some more definitions. Ironically enough, the next one is definition. It's kind of weird to define the word definition with a definition. But basically, a definition is a statement that is going to explain the meaning of a word or a phrase. It's going to clarify for us what exactly we're trying to say when we and describe what the word is or the phrase is or the figure. For example, the word collinear. It means it's on the same line. Just like we have the word co-worker, meaning two people who work together at the same place, collinear, this co meaning together, means points that are on the same line. Coplanar would be points that are on the same plane. So anything that is shared is going to be co-whatever. Alright, let's look at some more definitions. Geometry is all about the vocabulary. So for English language learners, this is a bit of a challenge because you are needing to think about what these words mean. And some of the words like plane, alright, you see the word plane, oops, I took away my marker. See the word plane, alright, that spelling has at least two meanings. It could be the geometric term plane, or it can mean like an airplane, which I can't draw because I'm an artist. There's my airplane. Alright, we'll put a fin on it. So there are a couple of meanings for the words, and you're going to see that a lot in geometry. Words that you've heard in other contexts, but now mean something totally different. And honestly, yeah, it can be confusing. Alright, the next word we have is line segment. So a line segment is a line that has been stopped at 2 points, and we call those points end points. Right? Oops. Let's fix that. Right, we call those points endpoints because they're the points that end the segment. So when we are identifying our line segment, just like we did with the line, we use capital letters, but instead of putting a line with arrows, we're going to put just a line with no arrows. This tells me that I'm talking about specifically a line segment. In geometry, we do a lot with just drawing lines and line segments loosely like this, but a lot of times we're going to be using coordinate geometry. So that means you need to have graph paper because you want to refer to specific points, draw the straight lines, and then use different formulas where necessary. So we have geometry as most people think about it, where you're just drawing on paper. And then we have coordinate geometry where you're actually on graph paper. All right. Next is the word congruent. Most of us are already familiar with the idea of congruent. It means is equal to, but we use it to refer to figures, not actual numbers. We wouldn't say 12 is congruent to 12, but we would say segment AC is congruent to segment DC. So things are only congruent, of course, if they have equal measure. So the words are similar, they're just not synonymous, meaning you can't use them interchangeably. Oops. All right, so let's say that line AC is measured to 3.2 centimeters, and then line CD is measured to 3.2 centimeters also. Well, since those measurements are equal, those two segments are congruent to each other. Notice that you have an equal sign and you have the congruent sign. So the congruent sign is very similar. It's basically an equal sign with a squiggly on top. Notice also when I wanted to say that something was congruent, I drew the two little marks on the segments. Right? When I notate it like that, that tells me that these things are congruent. So even if I didn't know what the measurement was, I could tell that the artist meant for these things to be congruent. So this is a good strategy to use if you're not that great of an artist and you don't have a straight edge, but you're trying to prove that something is congruent. Also, if we have a shape, like a rectangle, and we want to show that multiple things on the object are congruent, just not everything's congruent to everything else. So if I wanted to say that AD was congruent to BC, I could put 2 marks. That way, when I say that AB is congruent to DC, I'm not going to get my pairs of congruencies confused. So by having more than 1 mark, I'm just going to match it up. So if I see 2 here, I want to find the other side that has those 2 marks, and that will tell me, okay, these are congruent to each other. So it makes things a little bit easier. All right, midpoint, a little bit self-explanatory in the idea that a midpoint is a point in the middle of a line segment. So it bisects. And when I say the word bisect, I mean it takes a line and divides it into 2 equal parts. So H is the midpoint if line segment AH is congruent to line segment HB. So if those 2 things equal each other, then I know that H is the midpoint. The word bisect, I have it in bold on the screen. It's a very common word. You will see that a lot in geometry, and it means that something is being divided equally into 2 parts. All right, and our last slide for today, maybe not, is talking about a ray. So a ray is a part of a line that contains 1 endpoint and goes infinitely in the opposite direction. So let's say that I have this line here with these points, and I want to make B an endpoint. Well, if I want to make that an endpoint going in this direction, I would identify it with the capital letter B, and then either C or D, let's say D in this case, and I draw a ray above the 2 letters. Now, the left-hand letter always tells me the endpoint, and then the second letter shows me in which direction on the line it's going. For example, if I had, let's see a different color here. If I had going this way, all right, I would say that this is ray CA or ray CB, all right, because it tells me that C is the endpoint and it's going in the direction of B or A, depending on what that second letter is. The arrow itself doesn't matter the direction the arrow is pointing. Generally speaking, when you're labeling it, the arrow points to the right. It's not very particular that way. But this is not the same thing as saying ray AC, because ray AC means here's my endpoint and I'm going in that direction. So this is the one point that when we identify it, we do need to make sure that the order is correct, that whatever the first letter listed is the endpoint, and the other letter shows me the direction it's going in. All right, now that's all for the notes for today. We'll do some activities in class to help clarify some of these topics. And as usual, if you have any questions, feel free to email me.